All right. There we are. Welcome, everybody. Welcome to another live stream of PDAC. Explain it to me, PDAC. Sorry, I was making sure my phone was off. Glad you're here today. I'm going to scoot this over just a smidge. So, hope everybody is doing well. Hope everybody is coping and doing their best and staying safe and healthy and all that stuff, because that is all that we want. So I'm not going to prolong the time. As you see, we are doing adding and subtracting fractions today. So we're going to start with, and on my note cards to make sure I don't remember which things I'm doing, but we are doing adding and subtracting like denominators first, fractions with like denominators first, and then we're going to do adding and subtracting with different denominators second, and we're going to do 2 examples of each type because I don't want this to be super long. So let's see, let's start off with adding with like denominators. Let's see. First problem we're going to do is 4/5 plus 3/5. So when you're adding fractions, can you see that? Hopefully you can see that. I was trying not to get the glare of the light in the way, but hopefully you can see that. So when you are adding fractions and they have like denominators, all you have to do is add the numerators. That's literally all you have to do. So the denominator stays the same. Then 4 plus 3 is 7. Okay? So that's the basics of what you have to do. The denominator is the same. Just add the numerators. Now, some teachers are not going to accept this answer because, and I keep hitting this, I'm sorry, they're not going to accept this answer because it is an improper fraction. Improper fraction meaning the numerator is bigger than the denominator. So in order to change that into a proper fraction, what we have to do is see how many times 5 goes into 7 completely, and that's once. So that becomes a whole number. And then how many are left? So there's 2 left over. So then the 2 that are left over, that's the remainder. That becomes the numerator. And then the denominator stays the same. Okay? So that's how you turn an improper fraction into a proper fraction. So this is the correct answer. Pretty easy, right? Okay, let's do another one with like denominator. We're going to do 1/8 plus 5/8. You see me looking down, I'm looking at my cards because I'm organized this time. Same thing, we have like denominators, so all we have to do is add the numerators. So the denominator stays the same. 1 plus 5 is 6. Now, normally, you don't stop here because you can reduce the fraction. I say normally because, of course, it depends on what your teacher, what your child's teacher is asking them to do. But normally, the rule of thumb is if you can reduce a fraction, to go ahead and reduce it. And so to reduce it, we have to figure out what number goes into 6 and 8 completely evenly, and that's 2. So we're going to divide 2, divide 2. This needs to be the same number. So you wouldn't be able to do 6 divided by 3, then 8 divided by 4. You would have to divide both of these by 2 because what you do to the top, you have to do to the bottom. The same number. So 6 divided by 2 is 3, and 8 divided by 2 is 4. So now we have 3/4. So now we're going to say we are done because we can no longer, there's no more reducing to be done. So we're going to say we are done. So that is adding fractions with like denominators. It's pretty straightforward. When the denominators are the same, just add the numerators. If you come up with an improper fraction, turn it into a proper fraction. If you come up with a fraction that can be reduced, go ahead and reduce it. Okay? So I'm looking at my monitor. I'm hoping you can see that. And I cannot see your comments right now. So if you have any questions or need me to explain anything further, please leave a comment down below and I will do that. All right. So let's go to, we're going to stay with like denominators. And we are going to go to subtracting fractions with like denominators. So we have 3/8 minus 1/8. So just like with adding, when the denominator is the same, all you have to do is do the function for the numerators. So the denominator, because I can talk, is 8 for both, so it stays the same. And then the numerator is 3 minus 1. 3 minus 1 is 2. And just like with one of the previous examples, if you can reduce a fraction, go ahead and reduce it. So the number that can go into both 2 and 8 evenly is 2. So we're going to divide 2 up here, divide 2 down here. So let me scoot over my chair. That equals 2 divided by 2 is 1. 8 divided by 2 is 4. Can no longer reduce, so you're done. Okay? So the same thing when you're subtracting fractions with like denominators. Same thing, just bring the denominator over. Subtract the numerators. Reduce if you can. When you cannot reduce anymore, then you're done. Okay? Let's do another example. Subtracting with like denominators. We're going to do 4/5 minus 3/5. First thing you need to do, look at the denominators. Are they the same? Yes, they are. So that means the answer is going to be the same number, the same number that the denominator is. So then we're going to go to the numerators and subtract. So we have 4 minus 3. 4 minus 3 is 1. So we have 1/5 as our answer. Next thing you need to do, can you reduce this? Nope, it's all the way reduced, so you're done. So the answer is 1/5. Okay? So just to review, when you're subtracting fractions that have like denominators, you just subtract the numerator. So subtract the numerator, bring the denominator over. If you need to reduce, go ahead and reduce that. When you can't reduce anymore, then you're done. All right? Now let's go to adding fractions with different denominators. Let's get a clean slate here. All right. Get my adding note cards over. Okay, so we have 1/6 plus 1/3. I'm writing it this way because we have to do an extra step and I need some more room. So hopefully you can see that. We have 1/6 or 1/6 and 1/3, 1/3. Now when you're adding fractions that have different denominators, you need to find the lowest common denominator, or LCD, depending on, sometimes the books and the worksheets and the assignments use the acronym because it's quicker, takes less space, but LCD stands for lowest common denominator. So we need to find the LCD. That means what is the smallest number that both of these numbers go into, okay? How I would start and how I show my students to start figuring that out is absolutely you could write out the multiplication tables for 6 and 3. However, along with learning the process of different ways to do math, it's nice to know the shortcuts. So one of the shortcuts that I tell them is go ahead and multiply the denominators on both fractions, okay? So 6 times 3 is 18, all right? So we're going to turn both of these fractions into a fraction that has 18 as the denominator. All right? So we have 18 here. We have 18 here. Okay? So we need to multiply 6 by 3 to get 18. That means we're going to multiply 1 by 3. Because what you do to the denominator, you have to do to the numerator. Okay, so let's just go ahead and finish this. So we know 6 times 3 is 18. 1 times 3 is 3. Okay, now we're going to move down here. We know that 3 times 6 is 18. So what we do to the denominator, we have to do to the numerator. So we're going to multiply that by 6 also. 1 times 6 is 6. So now we can just add the fractions like we did before because we have like denominators. So I'm just going to rewrite it just for clarity's sake. So we have 3/18 plus 6/18. Okay? So now we're going to add. So we have like denominators. So it's not going to change. Then 3 plus 6, 6 plus 3 is 9. So now we have to look at it. Can we reduce it? We actually can. We can reduce it by 9, right? I'm going to stand up just a little bit. So that means we divide the numerator by 9 and we divide the denominator by 9. Can you still see that? Yes, I think you can. So 9 divided by 9 is 1 and 18 divided by 9 is 2. Okay? Can you see that? Hopefully you can see that. Yeah, I think you can see that. So we have 1/2 as our last fraction. We can't reduce it anymore. It's a proper fraction, so we're all good. So our answer is 1/2 or 1/2. Okay? All right, let's add again with, draw my top, with different denominators. Don't roll away, marker. Let's get a clean slate here. All right. So we have 2/5. And again, I'm going to write these two fractions along the side. We have 9/10. Okay? So we're adding. First thing you do is look at the denominators. Do we have the same or different? That's right. We have different. So we have a 5 and a 10. So we need to come up with the lowest common denominator for these two numbers. Now, the shortcut I showed you in the previous one, where it's just to multiply the denominator, the two denominators, we could do that so that our LCD, our lowest common denominator, would be 50. However, I bet there's a number smaller than 50 that both 5 and 10 go into. I bet there is. Now, could you use 50 with this problem and solve it and get the right problem? You actually could. You probably have to reduce a whole lot more times or a whole lot more, but you absolutely could use 50 and still get the right answer. However, like I said before, I tell them to do that as a starting point. Now, most people, most students know their 5s and their 10s really well. Their multiplication tables, the 5s and the 10s really well. And so it could be real easy to figure that out. However, if it's one that's not so easy, like 6 and 3, like in the previous example, for example, you can start out by multiplying those two and then going from there. But our LCD that we're going to work with today for these two is actually 20. So hopefully that's what you came up with. Okay? So we're going to change this to 20. We're going to change this to 20. All right? So 5 times what is 20? That's right, 4. What you do to the denominator, I don't know why I can't say that word today. I apologize. What you do to the denominator, you have to do to the numerator. Apparently, I can't say that either. So we have to multiply both by 4. So 2 times 4 is 8. Now, if you notice, I did this in the other example too. I'm not yet reducing this right here. Not yet. Not yet. Let's go down here and change this fraction. 10 times what is 20? That's right, it's 2. So we multiply the denominator by 2. So we have to multiply the numerator by 2. I can talk. I promise you I can. All right, so 9 times 2 is 18. All right, so now we have our two new fractions. I'm going to rewrite it just for clarity's sake. So we have 8/20 plus 18 20ths. Tongue twister. And so since we have the denominator, it's the same, we just move it on over. And 8 plus 18 is 26. Yes, it's 26. 26. All right, so now what do we have? An improper fraction. We have to move it to a proper fraction, so that's what we're going to do first. 20 goes with the 26. How many times evenly? Once. I'm just going to write it down here. once. How many is left over? 6. How do we know that? 26 minus 20 is 6, because 20 only goes into 26 one time. So then there's 6 left over from the 26. Hopefully that makes sense. Okay? So the remainder becomes a numerator, then the denominator stays the same. Oh, can we reduce? We sure can. 6/20. Can we reduce that? We can. If you ever don't know where to start, like I know I could reduce that, but I don't know with what number. If they're both even numbers, which they pretty much need to be to reduce, start with 2. Okay? So we're going to divide the 6, and we're only working with the 6/20. We're leaving the 1 alone. I'm going to divide the 6 by 2, going to divide the 20 by 2. Okay? So then that means 6 divided by 2 is 3. 20 divided by 2 is 10. So then we have 1 and 3/10. Can we reduce the 3/10 anymore? Nope. So are we done? Yep. So the answer is 1 and 3/10. Now, as you are going through this, you could have reduced these two right here when we got to 8/20 plus 18/20 and reduced it for here. You actually could have. I just chose not to. But if you did, you still would get to the same answer. I just chose not to. However, like I said before, would I go ahead and reduce here? No, I wouldn't, because you still need the denominators to be the same when you add, right? So if we were to reduce 8/20 and then 18/20, we might get different denominators again. And then you're back to square one with trying to find the same denominator. So after you find, the same denominator and transform the fractions, and then you're adding the 2 new fractions you got, you could reduce here. But for flow's sake, so that if you do mess up, you can find easily where you messed up, I just kept it the same and then just reduce at the end. Sometimes it's just easier just to do that. So there you go. There you go. All right, so that is adding with different denominators. So let's go ahead and do, my marker's trying to roll away, subtracting different denominators, and then we'll be done for today's live stream. Okay. So we have 9/10 minus 4/5. Okay? So we have different denominators, so we need to find the lowest common denominator. So like I said, you could multiply it, but coincidentally, and this was totally on accident, we have the same denominators that we had with the problem that we just did. So we know that they both can go into 20. So our lowest common denominator is 20. Okay. 10 times what is 20? That's right. It's 2. What you do to the bottom, you have to do to the top. What you do to the denominator, you have to do to the numerator. Told you I would get it. 9 times 2 is 18. Wow. Is that the same? It is. Wow, that was a coincidence. There was a 9/10 in the other problem too, but it's fine. It's fine. All right, so we have 4/5 and we're changing it to 20. So 5 times what is 20? That's right, it's 4. What you do to the bottom, you have to do to the top. 4 times 4 is what? 16. That's right. So we have 18/20 subtract minus 16/20 equals, we're going to write the 20 because the denominators are the same. Then 18 minus 16 is 2. All right, are we done? Not yet. We need to see, is it an improper fraction or proper? It's a proper fraction because the numerator is smaller than the denominator. And can we reduce it? We actually can, so we're not done. So we're going to reduce it by dividing both numbers by 2. What you do to the top, you do to the bottom. So 2 divided by 2 is 1. 20 divided by 2 is 10. Are we done now? I think we are, because we cannot reduce 1/10 anymore. Sorry, I dropped my mic. So, we're all done. That's the answer. Okay, let's erase. Let's erase. And we'll do another one. One more subtracting with different denominators. So we have 4/5, which I paused because I was looking, because there was a 4/5 in the other problem too. So that should be easy for us to figure out. Minus 3/7. Like I said in the other video, these are actually coming from worksheets that the students were getting. And sometimes the worksheets will do that. They'll help you along. So like in the problem we just did, it had a 4/5 in there. And so it kind of helps the students, I guess subconsciously sometimes, think, oh, if I did it in that other problem, I could do it in this problem because, oh, look, there's 4/5 again, type thing. You'll see a lot of that in some worksheets. I want to say in almost all maths. It just depends on what it is. Depending on what it is, depends on how it shows up, but you'll see some of that. You'll see some of it, but anyway. All right, so we have 4/5 minus 3/7. So we have different denominators, so we need to find the lowest common denominator. And so we're going to do the trick that I mentioned before with this one, where we're going to multiply the denominators. So 5 times 7 is 35. Okay, so we're going to change this to 35. We're going to change this to 35. 5 times what is 35? 7. Oh, sorry, I was going to move down here, but let's finish the fraction. 4 times 7 is 28. Then down here, 7 times what is 35? It's 5. What do you do to the bottom, you do to the top. 3 times 5 is 15. All right, so we are subtracting. So we have 28 over 35 minus 15 over 35. So we know that the denominator for the answer is 35 because we have like denominators. So then we're just going to subtract 8. So 28 minus 15. So because they are both double digits, meaning they both have two numbers in them, kind of use mental math here. So 8 minus 5 is 3. So that goes in the ones column. And then 2 minus 1 is 1. Okay? It's mental math. You could rewrite it and figure it out that way, but since this has 2 digits and that has 2 digits, it's easy to do it in your head. All right, so we have 13 35ths. Are we done? Let's check. Is it an improper, proper fraction? It's a proper fraction because the numerator is smaller than the denominator. Or can it be reduced anymore? The answer is no. I know that right off the bat. How do I know that? Glad you asked. Because they're both odd numbers. In order to reduce a fraction, you have to be able to evenly divide the numbers. You can only divide even numbers evenly. So if you have odd numbers, you can't do it. And I know that because I look at the last number in the number. We have a 3 and a 5. Those are both odd numbers, which means that the whole number is odd. Okay? So there we go. That's the answer. 13 35ths. So that was subtracting fractions with different denominators. So we went over adding and subtracting fractions with like denominators and adding and subtracting fractions with different denominators. So hopefully this helped. Hopefully you enjoyed it. Make sure you share this video with somebody that may be helped by it, and stay tuned for other live tutoring sessions. Also, make sure that you check out our YouTube video. Yesterday I put up a bunch of videos to help with math. So we have some algebra videos, we have some decimal videos, we have word problem videos up there, and some more stuff coming. So today's subject was actually brought to you by a request from a parent. Their child was working on adding and subtracting fractions, And so that's what we did. So if you have a question about something that your child is working on that you can't quite figure out and they can't quite figure out or remember how they did it in school, let us know. You can message the PDAC page. You can leave it in a comment underneath this video, or as soon as I stop this live stream and get back to my computer, in the comments, I'll put the webpage on our website where you can submit as many questions as you want. You can absolutely do that there too. So with that being said, thank you for tuning in. I appreciate you. I am now going to walk back to my computer and stop the live stream. Have a good day, everybody. Bye.